अभी आप अपने स्क्रीन पर देख रहे हैं, यह है प्रथम कोर चरण S139 बूस्टर का नोजल लेंथ सेगमेंट। इस प्रथम चरण के साथ ये शुरुआत होती है और यह मिडिल सेगमेंट को इसके ऊपर संयोजित किया जा रहा है। ऐसे 3 मिडिल सेगमेंट इसके ऊपर संयोजित किए जाएंगे और अंत में हेड एंड सेगमेंट सबसे ऊपर की ओर संयोजित किया जाएगा और इस तरह तैयार होता है PSLV का प्रथम चरण कोर बूस्टर S139। इसमें 139 टन का प्रणोदक होता है और यह इग्नाइटर है जो इसे प्रज्वलित करता है। इस मिशन पे यह है PSLV-C57 एक्सेल मिशन। तो इसमें है 6 स्ट्रेपॉन बूस्टर्स, हर एक में 12 टन के नोदक भरे जाते हैं। यह सब ठोस नोदक पर आधारित हैं। यह SI-TVC टैंक को उठाकर इसके साथ संयोजित किया जा रहा है। इंटरस्टेज आप देख रहे हैं, इसमें रिट्रो मोटर्स लगे हुए हैं पृथक्करण के लिए। और यह है द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है। इसमें विकास इंजन लगा हुआ है।
And here is the second stage of the PSLV rocket, prepared in the subsystem preparation facility and brought to the vehicle assembly building of the second launch pad to be integrated on the first stage of the rocket. Here you can see the third stage PS3 and PSO being moduled and placed inside the respective shroud and then handled together to be moved to the vehicle assembly building.
यह नज़ारा आप देख रहे हैं व्हीकल असेंबली बिल्डिंग का, जहां पर पूरे व्हीकल को असेंबल किया जाता है।
These are the visuals from the clean room of the spacecraft preparation facility. This is the Aditya L1 spacecraft being prepared and ensconced into a protective container where the environment is controlled and the temperature is controlled, the cleanliness is controlled. At the vehicle assembly building, again there is a clean room provision to safely integrate it to the rocket, and then the heat shield halves are closed. Now the vehicle is fully ready to be moved to the launch pad, which is about 900 meters away. This is PSLV.
The PSLV-C57 is prepared to launch the 1,480 kg Aditya L1 spacecraft into Earth-bound orbit, from which it will be placed into a halo orbit around the L1 point in 4 months. The satellite is intended to study the Sun and how it impacts the heliosphere. The Sun, which is the center of our solar system and has always fascinated humans, is a ball of hot gases formed by the nuclear fusion process. The visible outer surface of the Sun is known as the photosphere, followed by the chromosphere and then the corona. After initially dropping through the chromosphere, the Sun's temperature abruptly rises in the corona, reaching extremely high values of 1 to 3 million Kelvin. The Aditya L1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. The Visible Emission Line Coronagraph, VELC, investigates the solar corona and the dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SOOT payload, scans the solar disk in near ultraviolet light and detects fluctuations in solar irradiance. The Aditya Solar Wind Particle Experiment, ASPEX, and Plasma Analyzer Package for Aditya PAPA payloads investigate the solar wind and energetic ions, as well as their energy distributions. The Solar Low Energy X-ray Spectrometer, SOLEXIS, and the high-energy L1 orbiting X-ray spectrometer, Helios, analyze X-ray flares from the Sun over a wide energy range. The magnetometer payload is designed to measure the interplanetary magnetic field at the L1 point. Aditya L1 is equipped to take in situ measurements of charged particles and fields at L1 and is dedicated to studying the Sun across several energy bands. The Lagrange point L1 is located around 1.5 million kilometers from the Earth between the Sun and the Earth.
18 minutes and counting.
These observations are best made from a vantage point that provides a continuous view of the Sun. All payloads are designed in close coordination with ISRO centers and national laboratories like as IIA, IUCAA and PRL. With this mission, ISRO will once again demonstrate its position in space exploration.
Programs activated.
Minus 25 seconds.
PS2 VSPP open.
Minus 20 seconds.
PS1 ignition RMS
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Plus 10
Magnificent
seconds.
liftoff of PSLV-C57 with Aditya L1 on board.
Plus 15 seconds.
PSLV-C57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के
Plus
तेज से
25
विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही
Plus
एक और
30
कदम
seconds.
है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV-C57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday
Shuttle one
sky.
is in main auto.
A rocket launch is more than just a sight to behold.
First
The
stage
roaring sound
performance
and the
normal.
vibrations that we can feel
Shuttle
here.
is in main
Adding
auto.
to this, the thrill are just amazing. Ground lit and air lit strap-ons operating together with the first stage S139.
Ground lead strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रप ऑन को
First
सेपरेट कर
stage
दिया गया है
performance normal.
और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रप ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S139 motor still thrusting.
S139
First stage
110
separated.
सेकंड के प्रज्वलन
Second
काल के
stage
पश्चात
engine
उसे
started.
भी
Closed
पृथक
loop
कर दिया गया
guidance
है।
initiated.
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद
Second
उत्पन्न
stage
कर रहा है।
performance normal.
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation and the closed loop guidance has been initiated. According to the announcement by range
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे
Plus
यान
4
से
minutes.
पृथक कर दिया जाता है.
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है.
Second stage separated. Third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन
Third
काल
stage
समाप्त होने
performance
पर.
normal.
और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है.
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा. इस दौरान यह 240 किलोन्यूटन का प्रणोद उत्पन्न करेगा. वर्तमान में यान की ऊंचाई 134
Third
किलोमीटर
stage performance
तथा
normal.
सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड. जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV-C57 का.
For the present mission, after PS3 completes
Plus
its
6
burn
minutes.
duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में
Third
PS3
stage
का
action completed.
प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा.
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the
Vehicle
PS4
performance normal.
will start twice at predesignated times
Plus
and
7
duration.
minutes.
The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का, जो कि ग्राउंड स्टेशन द्वारा प्रसारित
Plus
किए
8
जा
minutes.
रहे हैं. वर्तमान में PS3 PS4 कंबाइंड कोस्टिंग फेज जारी है. यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है.
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakash Mandalasya Chakravati Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Jarhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth, the explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting. It is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक
Vehicle
पृथक कर दिया
performance
गया है
normal.
और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ।
Another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है। दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun will generate a forewarning about disturbances in near-Earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature, which cannot be replicated in lab. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 observatory or SOHO, which has been at L1 since 1996.
भी है क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृद्धि नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृद्धि प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere, and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle, and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer, or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Ultraviolet Imaging Telescope Suite, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE, and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer, or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer, or MAG, developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप, जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX, सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर, जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है, जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HE-L1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति निदभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य।
Cushion room. But the correct orbital parameters at the time of injection are of prime importance.
सौर मिशनों को नासा, ईसा, जर्मन
Aditya L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है। इसकी पुष्टि कर दी गई है।
PSLV-C57,
आदित्य L1
Aditya L1 mission accomplished. Handing over to mission director.
And we have a confirmation of Aditya L1 separation. The mission has been accomplished.
PSLV-C57 has injected Aditya L1 satellite into the desired intermediate orbit. PSLV-C57 Aditya L1 mission is accomplished.
आदित्य L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है। इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए। सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए। अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए।
Congratulations. The Aditya L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya L1 to put it in the right orbit. Now, from now, the Aditya L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh. So I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage, and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
May I request the Project Director of Aditya L1, Nigar Shaji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya L1, and I'm extremely happy that Aditya L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya L1 solar panels are deployed and the spacecraft will be normal. And Aditya L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans L1 injection, and finally insertion into the halo orbit in the Sun-Earth Lagrange point L1. Once this Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the Center Directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya L1 mission. Thank you all.
Sri Biju, the Mission Director and the Project Director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri MJ Lal, as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya L1 mission, just following the Chandrayaan 3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you.